Yes? Yeah, okay, good. All right. So, thank you, Klaus. First question, like, why is intelmq and AI together in one sentence here? Because everyone needs AI, right? So we're going to talk about exactly that, how we add ML support to intelmq, or aka how to babysit your LLM. And this is a talk from open source developers for fellow open source developers, or maybe also closed source, but it's really about our experience of how to combine that and lessons learned, so that maybe you can draw some of from this experience and apply it to your own, tools, right? What works, what doesn't work. So, briefly, my name is Kaplan. Here's Jürgen, Brandl, and that's Sebastian. And we don't speak necessarily for our employees or customers. So, what is intelmq? Quick show of hands, who knows intelmq? Whoa, quite a lot of people. So, it's a tool really for, that was developed in the context of national certs, 2013-14, because we got lots of feeds, let's say shadow server or so, and we needed to process them and send them out to the audience. So the audience would be ISPs or similar. So it works on structured data. That's important. It's not unstructured data. It's structured data, usually CSV files or something similar, or JSON files. It's used roughly by 600 plus IT security teams, and it's open source. And the idea was to have something very, very simple. Think Unix tools, like you have standard in some tool that processes it and standard out. So it's basically an ETL for IT security feeds. We talked about it in multiple conferences over the years. Internally, it has a JSON format, which we call events, which is always a timestamp and something like an IP address or a domain, and then the context, like what happened to this IP address at that time. So just to help you follow the talk, I summarized a little bit the lingo that we use in intelmq. A feed is something that comes in, like CSV file, shadow server, scanning data, vulnerabilities. This IP address is vulnerable to being a DDoS, UDP, DNS amplifier, things like that. A bot is a small program here. Yeah, you can see the mouse, that can actually do something. The internal intelmq data format is, think about it like the elastic schema that describes that. So, timestamp, IP, all these things. A parser is something that can transform and parse the unstructured, the structured report CSV file into the IDF format. An expert is something that transforms it. Output sends it to a database or to MISP in this case. So, big question: why would we ever do this statistical stochastic thing like LLMs? Why would we treat intelmq with that? Because intelmq is deterministic. It has structured data. Well, as I said, everyone needs AI these days. We can do a agentic chatbot, AGI, big data, whatever thing. But actually, on a more serious note, the question is how can we combine that? What would make sense? Can we use it for writing bots? intelmq bots. Is the LLM, is ChatGPT good enough for that? Sure, you can try it out, and all of you probably have that experience by now. You code something, and it sort of is correct, but then you spend hours debugging it because it didn't quite 100% work. So yeah, the question is, can we do that better? Or should we just use GitHub Copilot and Codex and whatever it's called? Can we write stuff for parsers? Can we write better documentation with it? Let's explore the options, and that's where Sebastian steps in.
Yes, looking at the possible intersections between intelmq and its concepts and LLMs, what they can provide, we discovered 3 different scenarios. The first one is already structured input data, which is already supported by intelmq and just needs configuration. The second scenario is structured input data that's not yet supported by a bot and needs some coding. And the third scenario is unstructured input and intelmq isn't made for that yet, so we need some magic. We will start by the first scenario, the structured input data. intelmq has a few so-called generic bots, which only need some kind of configuration to actually make use for that. For example, we will stick with CSV data feeds because that's the most simple form, and LLMs can parse that actually, so we can give a CSV feed to the LLM and it detects all the CSV related parameters like the limiter, the header, the column names, and so on. That works fine. It can detect that. The next part is it needs to find out which of these column names map to which internal data format field, which is first the field name and also the typing. And that's where all the LLMs are failing completely. Here's two examples with two different LLMs. Yeah, on the left-hand side we see on the bottom a configuration part, which was an output of LLM. It mapped the 3 columns of the CSV file to 3 intelmq data fields. The first one is actually correct. It did that fine. The second one, it said, is a malware hash, SHA-1. But actually, the feed was a SSL blacklist feed, and the SHA-1 is correct, but it's a SHA-1 of a certificate. It's a complete mess. The third one is kind of okayish. On the right-hand side, different LLM, similar problem, but this time the second and the third column were completely invented. They are never documented. It doesn't even exist. But at least the meaning is correct. And the right-hand side, that LLM even invented jump parameters which also don't exist in intelmq. It would fail. So that approach, just one shot, doesn't work. Pretty expected, actually. Some other issues that we found is that the LLMs didn't get the meanings that we find intuitive. For example, for source and destination, we think we know what source and destination mean, maybe from source to destination. But LLM, and most of them actually, even Claude, don't get that. They mix it up. It was never written explicitly in the documentation because we thought should be okay, right? LLMs don't understand that. One invented a new configuration format. We never used INIs, but it was there. I don't know. It uses old documentation, which is kind of expected as well, and then it invented stuff that doesn't work. We can solve all these problems actually with more explicit documentation and more explicit examples, because the documentation is actually also the prompt and the context that we provide to the LLMs, so we can mitigate these things a little bit. But we will come to that in the next scenario as well.
So we just seen that just writing configuration doesn't work already. And now the next question is whether if we have structured but unsupported data, so we have something that is available as a CSV, but that there is no bot for yet. Let's see how that goes. So the intuitive thing to do would be to use your chat interface of choice and give it a task to write me an intelmq bot for this feed. And quite interestingly, most LLMs know what intelmq is. Okay, all right. They know what intelmq is, but I think the best analogy is if you would hand me a basketball and tell me to throw a hoop, there is a slight chance that I might get it correct the first time around, but there is a very high probability that I will not shoot for the hoop. I can increase my odds by throwing the ball a repeated amount of times, or I can move closer to the hoop, but one-shot generation with LLMs, especially with chat interfaces, is a very similar problem. And it's similar because of a handful of reasons. For one, intelmq is not the big framework. It's not the Django of our time. It's quite niche, so there are not a lot of Stack Overflow questions that it could learn from. The question always is it in the training set? If it's in the training set of the LLM that we're using, if yes, is the code in there? Is the documentation in there? Is both in there? And the last question would be, if it's in there, how old is it? Because all LLMs have a knowledge cutoff date. And usually when you interact with a chat interface, the knowledge cutoff date is around 2023, 2024. So you're interacting with something that learned something a few years ago, but that doesn't necessarily mean that the knowledge is up to date. So if we change something in intelmq, the LLM doesn't know about it. And also, if you take something that a chat interface generated for you, you have no idea whether or not it works. So it could work, could not work, we don't know. And you could, in theory, copy that into some files, run intelmq, and collect error messages, but copying error messages back and forth is quite tedious. So raise of hands, who has used one of the tools on the list or something similar to that? Quite a few hands. If you haven't, I strongly recommend it because they feel quite magical. I have no other way of describing it. Basically, you tell Claude Code to do something. It can be a configuration change on your computer. It can be writing a project, and it does the whole thing. It writes the code, it compiles the code, it runs the code, it looks at the error messages, fixes the errors, compiles once again. It's basically an LLM in a loop. And it's quite awesome. But when we tried this, we used Claude Code in the latest version. We did the same thing we previously did. We said, here's a CSV file, write intelmq parser and bot for it, and it still failed spectacularly, which is quite interesting. To explain this, we need to go one level deeper. So this is something that AI has been able to do for quite a while. So around the same time where we had structured JSON output, we also had something that is called tool calling, which basically is you provide the LLM with a list of functions and the parameters and say, yeah, you can call that function. And in this example, the human asks the model, what is the weather in Hawaii? And the model translates this into a code function call, the get weather, with the parameter location Hawaii. And this is something that actually works. And you can build tooling around this. So there are frameworks like LangGraph, Pydantic AI, Crew AI, with which you can build your own agent. And this is what we did. So we tailored an agent specifically. Yeah, please. We tailored an agent specifically to the problem at hand. So our agent gets offered a few functions. The first one is to fetch something. So he can fetch the CSV file. To analyze something, he can analyze the CSV file. He can write code. He can get feedback for the code. So we have a few quality checks where we have things like, does this have a docstring? Does it use the right function? And the last thing it can do is it has a bare-bone intelmq installation on the side. And there it can basically test the code that it has written. So in the documentation, there is, okay, if the video doesn't work, I can show it on here. So basically, it is a web interface. You put in your request to write an intelmq bot. You put in the URL, and then the magic happens, and the blue things you see on the slides are the tool calls. So it basically called the validate bot quality tool, where it got feedback for the quality of the code. And then he ran the test in intelmq environment function, which took the code that our agent wrote, put it into intelmq, and on the right side you can see, if you look very closely, that it generated 8,500 events. So basically the code that we generated worked, but usually it doesn't work the first time around. And the nice thing with those agents and with the feedback loop here is that if it doesn't work first time around, it just gets the error message, it can adopt the code, write better code, and finally solve the problem. And in theory, you could do exactly the same with Claude Code or Gemini CLI, but you first would need to tell it to read the intelmq code base, to read the documentation, to set up an intelmq instance for you, and then it will still be difficult. So basically, we packaged a small version of that into a proof of concept. And the code is online on GitHub, but it's still proof of concept, and you need to be careful because you let an AI execute code and write files on your machine. which everyone in this room should know is very dangerous. Then there is an interesting thing I discovered, and that is that you want your code to work, and the AI also wants that your code works. And so sometimes it takes a shortcut, and the shortcut is it just says it works. Sometimes it makes a CLI call, echo, great success, but that doesn't necessarily mean it actually works. And you will soon discover if you ask questions. So what I did here, so it told me that we have a working production code, production quality code, and the grade is A+ with 95 out of 100 points. And I asked it, but does it pass the test in a real-world environment check? And then it discovers that, in fact, it doesn't work at all. There are errors all over the place, and it tries to basically mitigate the situation by telling me, it doesn't work, but let's see, yeah. And if we give it enough time, it will figure out how it actually works. Most of the time, sometimes it never knows. And you still need to have a sanity check. So you need to be the feedback loop, you need to look at the code, because LLM is a notorious liar and it will lie to you with no problem at all. So here the updated grade is a D+ with 65 out of 100 points. And the code didn't change. It just, if you ask the question, does it actually work? It realizes it doesn't, and it will tell you the truth. But basically always assume that you're being lied to.
Yeah. Coming back to the previous topic of documentation, we found a rather unexpected finding. From the perspective of a tool maintainer or a developer or a tool expert, we write documentation. But the documentation is often for newcomers to the tool, not for the experts. At least many parts of the documentation. And we need to write that for newcomers. How can we do that? We always have that expert knowledge in our brain, and even unintuitively we use that. We can ask for feedback from other people. Sometimes we even get feedback, and the first time we do that, that person is basically already used, because the point when someone does that, he's not anymore a newcomer. So LLMs can actually help for that, because the documentation that we write for newcomers is very similar to the documentation that we write for the LLMs, and that's the prompt and the context that we write. We can reset the LLM's brain, basically, and make it think you are a new user to that, and you can do that as well, do that for again. So you give it a task, configure a bot, test it with the documentation that you have, you find out the documentation is lacking something, then you improve the documentation, then you go back, retest it with the LLM, and maybe, hopefully, the task did now succeed. You have kind of now the possibility to make unit tests for documentation, not only for code, which is quite neat. Of course, LLMs behave different than humans, but still LLMs can be a good, valuable input for documentation authors, nevertheless.
Okay. So, third category is unstructured data in, and it's not supported yet by intelmq. So, we did some prior research on that, like parsing unstructured data, like mostly CTI reports. We presented at first and at multiple conferences, for a framework that we call CTI.tools. And yeah, there were benchmarks there, evaluating how good each information gets extracted, how to map it, and for our case, how to map it to the intelmq internal data format is relevant. Yeah? So what can we extract here? Get the unstructured text, CTI report, for example, into the LLM, and tell the LLM how to match each thing into the intelmq internal data format. For that, we used another agentic framework, which Jürgen already mentioned, Pydantic AI, which is pretty nice. So I like it because it's gives you the type checking and the structured output for free. But the questions are always like, you'll see it in a minute. Are the fields filled in properly? Yes, with the structured and the pedantic AI, yes. But is everything covered? Could it extract everything that it could extract, that we humans could extract? And is it correct? And is it correctly assigned? And then another big thing is a CTI report is something else than the intelmq IDF data format. The data format is like log files, right? Timestamp, IP, what happens. And CTI reports are graphs, actually. So it doesn't 100% fit. But anyway, we tried it. Here is a demo of a report from oracle.eu. I recommend that site for public CTI reports. Here you see one sample report, which is public, talks about recorded future, analyzed how Ukraine's Roundcube servers were attacked. So just keep that in mind for, this is basically happening then. In the report. So I execute the code of the bot for that. It goes to GPT-4o in this case, but you can also direct it towards a local model, which is quite relevant if you have more like internal infos. And yeah, it extracted 7 events, intelmq events from that, stored it to a JSON format, and this is how it looks. Now, from the report, it gave it a correct classification. This talks about malware. That's okay. It correctly extracted the hashes. It gave it the context. And here is a difference from IOC extraction with regular expressions. With regular expressions, yes, you can extract hashes, IPs, etc. But the LLM has the advantage that it understands context. Where was that said, right? Is it just a URL linking to in this case, recorded future? That's probably not interesting. So we can play more with that. So there, I do see some value with information extraction here with LLMs, but it sometimes gets it wrong. So, for example, if you look at this one, here, I don't know if you can read that, it's malicious code, says it's classification malicious code, and it says a malware hash MD5, and then it gives a file name or path. That is obviously wrong. Yeah. So that underlines that main point of the talk is, yes, LLMs are interesting, are great, we can use them in our open source project to code, to improve documentation, etc. But you always need that feedback loop. You need that in French crèche or kindergarten, right? To have that baby there, and so that it can't go off to do something really stupid. Yeah. So in the intelmq, to go back to the bots, we have a collector. In this case, the Oracle collector. We have that unstructured text parser that I just demoed. And then we finally, because we promised it, we're here with Circle, we export to MISP. So yes, converting that to a MISP feed was a minor, fast job. That was nice. And here you see the data as a MISP feed. So basically MISP feeds are nice to import into MISP. And that's pretty much the talk already. I don't know how we're looking on time. Klaus? Okay, well, I'll try to, okay, perfect. I'll try to summarize it again. It's for the LLM, we start to really write documentation not only for humans, but also for the LLM. It's great to test the documentation with an LLM if it can write something based on that. Agents are not magic. They're, notorious liars. LLMs are. But you can make it a little bit better by putting it into that environment, that gym, that feedback loop, that kindergarten, where they can test it out against actual unit tests, Python unit tests. Trust but verify, and pedantic AI and similar frameworks are nice because they give you type checking on this unstructured stuff. And here are 2 links to the project, intelmq, the main project, and then the botgen that you wrote, which is, I think, pretty amazing. And I think we're going to expand intelmq, add 50 bots now and have them generated and automatically self-tested. And that's the cool thing about this talk, I think. My personal opinion. Thank you, co-speakers. Okay.
Thank you very much. If we have the next, we might be able to do a few questions if there are, while they get mic'd up.
If you have time.
Yeah. So getting mic'd up is Stanislav Dashevsky and Francesco Laspina. While they get microphones, or if you get me to set up, okay. So if you get mics and then set up, I'll take one question meanwhile. Any questions? No. All right. Then let's just finish here. Thanks a lot.
Thank you.